Thank you, Andy. Thanks to Sarah and everybody else for asking me to be here today. It's a great honor to be here, and robotics is a huge, significant passion of mine, and Sarah asked me to put together a vision for robotics. So this will talk about some of the areas I think we need to go and where we're going in robotics, and have some fun with it too. We'll talk a little bit about magic and talk about some of the areas where I think the robotics industry, at least the government, needs to really, the defense sector needs to partner. Can you go to the next one, please? Let me ask you real quick here. Do you have sound on there? Because I have a few films on here. Well, there'll be some sound.
I believe so.
Beautiful. Okay, so right there, Little David, that's from 1956. That's at Aberdeen Proving Ground. So robotics is not new. Robotics has been around quite a long time, and actually the military experimented with robotics. If you go to the next one, please, and click that.
Welcome back to Mail Call. I've taken the old Mail Call screening room out of mothballs because I have got some rare footage here
There you go.
that you have got to see to believe. I was inspired to show it to you when I got an email from JP in Stafford, Virginia. He's asking about a crazy experiment called Little David. This one's for you, JP. There it goes, roaring across the test facility at the Aberdeen Proving Grounds, Maryland in the 1960s. A radio-controlled vehicle capable of a blistering 35 miles per hour with its two-cycle engine. The Little David was originally built as a platform for demolition, cheap, light, and expendable, and capable of carrying 250 pounds of payload. And just look at
The first mule.
it's got.
I really don't think it's voice actuated.
Wow, it even goes forward. Look at it, go over those punny.
So we don't have to keep going here. It's when we just go ahead, yeah. So, I mean, he goes on and on and on, and even though all the different things you can do with that, the military never adopted that, but it was a precursor, of course, to a lot of great military robotics that went on, and the military didn't adopt it, and it's one of the issues the military and the technology community struggles with every day is we didn't have a requirement for it. There was nothing that said we should have an unmanned vehicle that do all these different things because we already had soldiers or other kinds of activities. So even so, back in 1957, it wasn't something that was, even though it was great technology and it could do a lot of great things, there was no requirements for that. And even here it is 54 years later, and we're still struggling with those issues, and I'll talk a little bit about where we're making some inroads of that. So now, I couldn't go into this talk without really mentioning sci-fi inspiration. Even in bad sci-fi movies or not so good sci-fi movies, you come up with things, and it's really amazing because, where's Dan? There you are. Dan Bartz and I were talking. Dan and I worked together, and we were talking about sci-fi inspiration and some of the things I wanted to talk about. Like, let's see, is that your upper left? That's Forbidden Planet, a great classic 50s science fiction, which introduced the idea of humanoid robots, Robbie the Robot. I mean, robots go a lot further back. Rossum's Universal Robots were the first time it was actually mentioned in literature. But if you go down there to the bottom left-hand corner, that's a clip from 2001: A Space Odyssey, I think, 1966. And look at that thing he's reading. It's called a newspad in 1966. It looks kind of familiar. Matter of fact, I'm staring at one. I got one over here. It is basically the precursor to the iPad. And between those two, you're looking there at Will Smith and I, Robot, and a really butchered movie. But the interesting thing was about that movie was it demonstrated this notion of shared driving, which is really present in today's car. Any vehicles that actually have adaptive cruise control, the car is responsible for doing the headway. You as a driver are responsible for actually keeping lane and making smart decisions, moving from lane to lane. That is a shared driving. And in that movie, there's a scene actually where Will Smith is allowing the car to drive and he switches over and drives himself. And that seamless being able to do that is actually, again, forecasting where we're going with that. And remarkably enough, Minority Report, which was in 2002, which had a lot of great technical scientific minds actually advising that, really has laid out 4 areas which we see, or at least 3 of them, and a 4th coming where we see technology going. That top right corner, again, you look at that with the fact that Tom Cruise is being able to pull, the connect with what we're actually able to do, again, with iPads, with the capacitant type touch. The middle one, the small micro robotics and swarming robots. And again, you'll hear from Ed Olson this afternoon, but swarming robots is something the military is heavily working on, and actually there is a very significant program in the military working on micro and nano robotics. That third one down on the far right is being able to do face recognition, and in this case in the movie it was retina recognition, but doing direct focus targeting, advertising and shopping capabilities for a person as they're walking through a mall. And that last lower montage is this notion of this totally enabled intelligent highways where the driving is done entirely by automobiles and the person is in the car and he is doing whatever he wants to do, and in Tom Cruise's case he's escaping from the car. So if you can go to the next one, please. So you see here that, I mean, I'm at Tardec, I've been there for about 25 years, been involved with robots one way, shape, or form actually since the mid to late 80s. And you look across there, and we do a lot of different things. And you see that little icon up there. It's supposed to be a document where we were looking into how do we, as the technology group, start really working with the requirements people to really start defining what are requirements, what is the art of the possible. And besides doing all that, we move across here. We do analysis, research, component, design and testing, integration in the platforms, actually integrating the platforms, and if successful, we hopefully transition that to the military, to the soldier. And again, there's a friend of mine, Mike Toscano, who's the executive director of AUVSI, always talks about if we're not fielding, we're failing, and we all totally agree with him. So from the robotics community standpoint, that's what we're trying to do. And on the left-hand side and the bottom, you see there, we are doing a lot for the current fight. There's a lot of activities, obviously, going on in Iraq. Of course, we're doing a drill down in Iraq, and the activities going on in Afghanistan. But we've done a lot of work in terms of providing quick reaction, urgent needs type robotics appliques, types of responses to that. But we still have an eye out toward where we're going in the future. So you see that little film there, and actually that film was created for me by Quantum Signal here in Ann Arbor, a friend of mine, Mitch Rode, and his staff, on this notion I call it Ender's Table, where we can control a predator from 5,000 miles. What would it take, or what could it look like if we controlled ground robotics or a swarm or a team of heterogeneous robots from a long distance? What kind of information would we need? And you see on there also we're looking at, you know, it's coming, but militarized or armed robotics, as well as some of the advanced high-speed platforms. You heard Andy talk about it. It's a real passion of mine, seeing robots move faster. And that one interesting image there is the exoskeleton, which is a reality. Right now it's powered, it's tethered, and you can look at a soldier lifting 90-pound iso packs for about 90 minutes and not even breaking a sweat. Matter of fact, I think I had an image on the other one showing the Avatar from the movie Avatar, the AMP suit. And again, those kind of things are actually being worked on by the military. So even in some cases, sci-fi, give us a preclusion of what's going to happen in the future. You can go to the next one, please. So from a strength standpoint, and it's something that, we really kind of leverage, this outreach in universities. It's been a passion of mine to do as much outreach and university involvement as possible, and we continue to do that with events like First Robotics, the International Ground Vehicle Competition, or I should say the Intelligent Ground Vehicle Competition. I think we're in our 19th year. We're the oldest outdoor ground robotics competition in the world, and we're celebrating our 19th year this year at Oakland University. Again, this requirements, more and more we're working with automotive OEMs and suppliers. International I'll talk about, and again, you see a bunch of robots there. I don't think those are the first the Team Michigan robots. Can't see from here, but so all these different things we get involved with. So we got all these strengths, we got all this direction, but what does that mean for vision? So if you go to the next one, please. So there are some key drivers going on, and Jeff Jakowski is here. He's Deputy Program Manager for the Robotic Systems Joint Project Office. The interesting thing here is, I show like 162 robots, something in 2004, and I know it's more around 4,000 or 3,600 right now, but at one point, 6,000 robots being deployed at various locations around the globe. All of those teleoperated or remote controlled, no intelligence, and for a lot of reasons. Not that the technology doesn't exist, but again, the requirements and some of the issues regarding safety. So from another key driver is looking at soldiers or humans and robots. Don't look at them separately, look at them as a team. And when you start looking at soldiers and robots as a team, you start getting some interesting drivers. Like I said, when the human is supporting the robot, well, what you're looking at there is currently you're in a situation where, like for a Predator, you need as many as 15 to 16 people on the support staff to fly one robot. So when you're trying to make the argument to the military and to our leaders saying this is cost effective, they can push back and say, no, this isn't. You got 16 people doing this job, which you didn't take before. So you can see here, I got on the horizontal and the independent axis there, this notion of mission complexity. So as in the vertical axis would be the number of support folks on it. So when the human is supporting, what's happening is we get more and more complex missions. We're going to need more and more humans. So we have an obvious goal. We want to drive down the number of operators operating robots with an end goal would be great to be zero. You know, have it running autonomously. And matter of fact, one of the things we did was about the Magic competition was to specifically structure a competition that would allow us to actually go after that ratio. Small number of users, lots and lots of robots. On the other hand, it's human is being supported by robots. And in that case, at the high end there, I'm looking at a robot acting independently. Maybe a lower level is a robot that's loosely watched, a robot that's ideally scripted, I've scripted everything, or the final one is a robot is always in control by the user. And the idea there, and you can see that goes down, so as mission complexity goes down, it's a dual of what we talked about before. We're talking about in that situation, always going to have direct control. And again, we want to take the user away from having to always look at the robot. So the goal there is to allow the robot to be more intelligent. So those two, when you look at that kind of teaming, it drives out 4 different areas of research that I myself and other labs and other organizations around the United States are working on. And across the bottom there, you have one of the big issues for me, it's reliability. And again, being here at NCMS, they're well aware of that. Reliability and system failures happen for a variety of reasons. Not only design, not only manufacturing, but it's been used incorrectly, it's been used in the wrong environment, or it's been maintained incorrectly. So there's a lot of different modalities when we talk about reliability. The second one is interoperability. I have another chart I didn't put in here, but that graphic is a real classic graphic. It shows up in a lot of different conferences as the vision of the future. We're going to have UAVs, different class of UAVs. We're going to have ground. We're going to have dismount. We're going to have all these different things going on. We're all going to be connected. Oh, by the way, how many controllers? And I asked the guys in the lab to put up how many different controllers would actually be needed for that scenario, and I think they found like 22 different controllers. So this notion of multiple controllers is just not acceptable for our military and our soldiers to carry around all this kind of equipment. So one of the real key things that we're driving down to is the notion of interoperability and standards for this. The third one shows, actually it's a SMET, it's a Lockheed Martin, I mean not SMET, it's SMSS. It's a Lockheed Martin, but what we're really looking at is platforms and payloads. What are we doing in terms of actually taking vehicles and making them robotic, making them taking advantage of the intrinsic mobility, intelligent mobility of the systems. And the last one is a clip from that earlier video showed, which is this notion of intelligent control and just the user control interface. Can you go to the next one, please? So from a robotics effort, there's a bunch of different things we're doing, and across the back too there, you see I've got MAST, and MAST is the Micro-Autonomous Systems and Technology, and then there's a Robotics CTA. Those are going on at Army Research Labs in Adelphi, Maryland. Those are very core fundamental research activities going on. The Micro-Autonomous looks at not only flying, but we're looking at indoor flying, things like quadcopters, looking at microelectronics. If I'm not mistaken, University of Michigan, there's there's 4 different thrust areas in there. The University of Michigan, I think, leads the microelectronics and structures area. If anybody's here from Michigan on that, they can correct me on that. But their end goal is to have a handful of small robots that they can carry around, a soldier can carry around, much like they showed in Minority Report, to deploy into a building, that final 100 yards, so to speak. So you can get your military to move, vast miles across desert and all kinds of different terrain, but that last 100 yards to get into a building or engage an area, sometimes that's what these micro robots are being looked at as supporting the soldiers. Robotics CTA, that's actually been going on. This is the second version of the Robotics CTA, and that's actually being run by a CTA as a Collaborative Technology Alliance, and that particular CTA is being run by both Carnegie Mellon and General Dynamics Robotics Systems, and there's a lot of different partners in there, and they're looking at some of the classic problems in robotics. Machine intelligence, looking at perception, looking at payloads and manipulators, and looking at user interfaces. And so from my standpoint, I look at those results, and I try to transition those into test beds to test out what they have, and to really kind of help define requirements, help define what's the best in breed of what's actually out there, so that when we write requirements, they are achievable, doable requirements. And then we can do all the different things that we have to do in terms of, fleshing out whether or not these are cost effective or not. A couple other ones in there. I'll talk about the rodeo, and then I'll go to these other two. Rodeos are an opportunity when there is industry and academia who've done stuff beyond just research test bench. They've got some really good work they want to demonstrate. We've been having these rodeos. Rodeos seem to be the term du jour right now within the military, to bring all your technology and be able to show it, and show it to some of the leaders, some of the people, again, making the decisions and helping us decide where we are in terms of state of the art and marketability and the performance of these. The middle two, Magic and these platforms here. I think the next slide I have is about Magic. Let me just talk real quickly about Magic. We were approached actually like in June of 2008. Would we like to do a competition with Australia? And United States and India just had co-sponsored a micro-autonomous air vehicle in India. And there was some measure of success, but they wanted the U.S. and the Australians to work together. So we worked about a year actually trying to put together a competition. We came up with the Magic Multi-Autonomous Ground Robotic International Challenge, and I think we'll run a film here, and that will show some of the details. You can go to the next one, please. Yeah, if you could just click on that. Oh, just go back, please. Okay. Just actually click on the image, if you wouldn't mind. There you go, should work. There you go.
In July 2009, in answer to a growing military and humanitarian need to accelerate the evolution of unmanned...
That's when the official announcement came out in July 2009.
The U.S. Army Research, Development and Engineering Command, in partnership with the Australian Defence Science and Technology Organization, launched an unprecedented worldwide search for prototype UGV solutions with the ability to autonomously and dynamically coordinate, plan, and carry out intelligence, surveillance, and reconnaissance tasks against changing priorities. From an initial field of 23 competitors from across the globe, 5 finalist teams met in Adelaide, Australia in November 2010 to participate in the first ever Multi-Autonomous Ground Robotic International Challenge, or MAGIC. This grueling 3-phase course required each team to demonstrate the use of multi-vehicle robotic teams that could work together safely, efficiently, and effectively to explore and map a defined challenge area, to correctly detect, locate, classify, track, and neutralize objects of interest, to combine information from all UGVs and compare that data with actual on-the-ground information to evaluate performance, to employ a maximum of 2 operators to supervise at least 3 UGVs, and to complete a series of increasingly complex exercises within a 3.5-hour time frame.
And before you go to the next one, so the Magic competition, again, so you heard that, no more than 2 operators, no less than 3 robots. So based on the rules, they actually physically had to flip the ratio what we're normally used to. The U of M team, I'll brag on them, 14 robots, 2 operators, was pretty remarkable. The second place team was University of Pennsylvania. They had 7 robots running with 2 operators, and a conglomerate of robotics research, NREC, National Robotics Engineering Center, and a few other organizations finished in third place with a really great performance, two operators and 7 robots. Actually, tomorrow I'm hosting, as part of National Robotics Week, a technical brief out, if you want to call it, a workshop at U.S. Army Tardac, and everybody's invited to come if you're a U.S. citizen. Just let me know, and then I'll make sure you guys get on the invite list if you want to be able to come and hear this tomorrow. Go on the next one, please. You're going to need to click on all 3. Can you click on all of them? Yeah. That one and that one. Click on that one. Should. Click on that one too. Is that going? Oh, okay. All right. Well, unfortunately, so those are 3 of our top platforms. On the far left is CAS. That's Convoy Active Safety Technologies, and it fits into that category where it's a test bed where we're trying to pull in different technologies and try this out. Now, convoying is what we consider low-hanging fruit, and I don't know if Jeff later on is going to talk about some of the applications and what we're currently using robotics for, and we're using them for, it's in the papers, IED missions. They've been just tremendous helping out our warfighters in terms of helping them locate and detonate, and really, again, you know, when a robot blows up, it's a good thing. That means, you know, some of our warfighters didn't, which is, you know, God bless the robots in that event there. So, but logistics and convoying is looked at as a real low-hanging fruit that we should be able to be doing. And again, not only because of technology we've helped develop internally in our own lab, but what's going on in the auto industry and in the trucking industry. On that bottom right, it was actually our APD, our Advanced Platform Demonstrator. It represents, from a large vehicle standpoint, our state-of-the-art. It's an 8x8 hybrid vehicle, and there it goes. That one has a speed, I think they were able to run this up to about 45 or 50 miles an hour on a straightaway. It was remote controlled. They're still checking to see if that's actually a world record for this route. That's an 8-ton vehicle. Look at the kind of maneuverability it has. It really was looked at more of a test bed, again, to try autonomy, but there's some real goodness to it, and actually NREC, one of the developers of that, has now put together what they call their mini version of that. And maybe I didn't pull the film over, I thought I did, but that other one there is a vehicle called SafeOps, and that idea is a vehicle that can follow the rules of the road. So it understands lane following, understands stop signs, traffic signs, and it identifies pedestrians around there and makes the right decision in terms of slowing down, and these are all critical issues. So besides the current IED mission, we're looking at where we can expand robotics and where it makes sense in terms of a cost benefit for robotics in the future. So if you go on, please, and I got a few more slides and I'll be done here. To go on, so this autonomy spectrum I put up there, and I'll just cover this real quickly. The interesting thing is, if you start looking at that soldier-robot teaming I talked about, what you're really interested in, and I kind of, you know, foreshadowed that notion of this Ender's table, can I be far away in controlling robots? And so you look at this, and the way that's kind of looked at is we're really good at 0 to 50 meters. You can keep your eyes on the robot and you can see what's doing. It really doesn't do a whole lot in terms of mission. You can do some car inspection, which is important. Anytime we can separate, you know, I mean, a soldier's job is to go into harm's way. We're not telling him that he's not going to go into harm's way. We're going to give him more tools to be able to be safer, and that's what we really, way we look at that. So 0 to 50 meters, we're really good at controlling things because you got your eyes on it, and kids know how to do that, and these young soldiers, they probably played with this kind of stuff. 0 to 500 meters, we're pretty good at that too. Line of sight, comms is still an issue, right? So, and it might even be beyond 500 meters. And being the engineer in me, I started looking at magnitude 0 to 500, 0 to 5,000, on and on and on. And what I wanted to do was, well, if you increased in magnitude the separation distance, what kind of missions would you have, and but what would be the technical challenges? And of course, as we're moving up that, you're looking at increasing autonomy, but really what's not on there is not only are you looking at increasing autonomy, and it's something really exciting that our leaders have figured out, it's also increasing reliability. These systems, if they're going to be integrated into a military culture, they have to be trusted. So it's a cultural and it's a trust situation. And so one of my goals and one of the vision that I have is robotics approaching the kind of reliability levels we have in the commercial automotive industry, which is somewhat controversial, but more and more folks are kind of like gathering around that idea, saying, you know what, that's not a bad idea. The legend on the side are showing you different robotic platforms that actually kind of fall against that spectrum, and where we are and how they got into field, or those yellow triangles, I think it looks yellow up there, on where we are in terms of requirements and stuff. So we're actually writing requirements documents that fall along those different areas. So it's a good chart, and like I said, it's one way of looking at autonomy spectrum. But if you go to the next one, what we're really missing here is I'm pulling the soldiers apart, but more and more we're being asked to do something a little bit different. And again, and this is why the need to get more involved with what's going on in commercial automotive. Because our current fleet, and I'll call it the intelligent ground vehicle fleet, we have all those vehicles on the left side, and they're manned. You got MRAPs, you got M1s, you got Humvees and such, and more we're slowly including some of this quote-unquote intelligent technology into those vehicles. MRAPs, have been great in terms of protecting soldiers from improvised explosive devices. They're really difficult to drive. You can't see the wheel wells. It's really, especially in Afghanistan and where they've been. So now we're actually giving some imagery from cameras that we would normally use on robots, and we're actually piping that imagery in so that these guys can better drive. So we're starting including intelligent technology in manned vehicles. And I've talked ad nauseum already about all the unmanned vehicles, but now more and more we're seeing this new area, and I'm not going to say it's an official designation by the military. You see more and more people using it. Is this notion of optionally manned. And again, kind of going back to what I talked about Will Smith and in the abomination that was iRobot. But in that particular case, optionally manned is the idea is I want to rapidly be able to move in and out of a vehicle with, I don't want a 4-hour turnaround to make a vehicle unmanned or make it manned again. If the soldier wants to use that to move it in front of a convoy, to use it as a decoy for IED, and if he needs to jump into that, I want it to be instantaneous. So this optionally manned, and if we're going to go optionally manned, you can go to the next one. If you're going to go to the optionally manned, that means we need to start dealing with these different organizations. So real quickly here, I'm going to have to, we'll time this, hit it, go ahead. One more, and one more. So this, I've talked about this before, this innovation cycle, and more I think the military is actually looking at this is a way of leveraging IRAD and leveraging a significant community, the maker community. So those are images, and just representing the innovation. That's an image of like ENIAC 1 from the 40s. This commercial is IBM. It's an IBM, I think 360 or 1170 or VAX 1170 from Houston Control. And then, of course, in the 70s, you had the Homebrew Computer Club that was coming out. Of course, guys were playing with Apple IIes and the Commodores and stuff, and really spawned a bunch of people who were really excited about robotics. You go to the next one, and it flipped. And it totally flipped. So these guys who were the maker space, one more, please. The ones who were the hacker space became, the giants, and in some ways, actually, Apple's looked now as the evil empire. But Apple, Jobs and Wozniak, really created a revolution. And then they spun off organizations like Google, and of course, and there's Zuckerberg with Facebook. And the amazing thing is, so it's gone full circle. So now you have DARPA using this technology in order to look at crowdsourcing. So that image of the United States with a red balloon in it, there was a DARPA challenge, which they thought would take weeks to solve, which was release 12 of those weather balloons, and have them maybe like 100, 200 feet off the ground. It wouldn't be floating free. And on a certain time and a certain date, we're going to release 12 in the United States. The first team to locate all 12 wins some significant prize. And it turned out, I think the team was from MIT, and it was somebody using Facebook. And all they did was they said, we'll give you whatever it was, $25 reward if you tell us where these were. So what the experts thought would take weeks took 3 hours, using this technology that in some ways was spawned by the government investing in all of these activities. So this is a huge space to really leverage. So I've talked to some people about this before. I've said this at briefings. I think the great changes and revolution in robotics are being done by the hackers and will be done by the hacker space that's really starting to stand up in this community. Go to the next one, please. So the final challenges I'll leave out here. So you see a lot of different things. You see that guy who is talking, drinking. He's probably got a burger in his lab. Who knows? He's doing all these different things. That was kind of me driving here. I was looking at directions. I was running late. But, you know, in Larry Burns has talked about it, the driving is becoming the distraction. It's not distracted driver, the driving's becoming the distraction. So utilizing these technologies is absolutely critical to do. And there's all kinds of different areas we can go. I mean, some of these images down there, I'm showing just like a cityscape using like dynamic short-range communication, DSRC, and, you know, vehicle to X, whether it's vehicle to vehicle or vehicle to infrastructure. You know, I have a couple other graphics up there, you know, really leveraging what's going on in the game community. Right there in the middle of there, if you recognize it, that's a Kinect motion system for the Xbox 360. And there's all kinds of interesting things and applications, and as Dan educated me on this, I mean, within 3 days of the introduction of it, there was already a hack on the internet, and everybody started using this to start controlling robots and computers just based on a game technology that's totally revolutionary. It's totally disruptive in this community. Using graphics processing, you know, GPUs that are, you know, instead of, we talk about Moore's Law, but when you start talking about parallel processing, you get into this notion of bending Moore's Law. So Moore's Law no longer is maybe 18 months, especially if you start looking at the effects of using graphic processing units, and the power consumption are those, which is a huge issue on robots, is significantly less than what we're currently using in terms of power consumption and heat abatement on standard GPUs. Now, does anybody know who those two people are up there? Dan, you can't say. Anybody know? Henry Ford. What was the other guy? That's Elijah Otis. And I put these two up there for. I put these up there, okay, elevator, right. Okay, 2 reasons. So we get challenged all the time saying, okay, you know, we're constantly being told, can't run those robots, they're not safe. And one of the things we're trying to crack this code is how do we, you know, go from where we are currently with robotics to being able to test these out. And I'll give you one final thing after this. But I'll just give real quickly. Elijah Otis, and I just found this out recently, again, thanks to Mike Toscano. So in 1858, I think the tallest building in the United States at that time was something like 6 stories. And not because technology didn't exist, because people didn't want to walk upstairs. And building code would not allow them to put elevators in because they were unsafe, even though elevators have been around since before the time of Christ. I mean, they, you know, we were talking about pulleys, so they were unsafe until Otis showed people he could go up 4 stories and he cut the cord and the elevator didn't fall. So it was still, then there was some changes in the laws that happened, but something like 1880 when there was actually like a screw drive, electric drive motor came in, when they said, okay, they were fine, you could build them. Overnight it changed the entire United States landscape, because buildings that were 6 stories and cities that were spreading out now started going up. So, I mean, Otis, who's not necessarily given the credit, totally changed the world with the invention of the elevator and making it safe. And people, and even in the 1920s and 30s, they still felt it needed a driver in there. So, you know, these great old movies and these throwbacks where you see somebody operating the elevator, that's not just a nicety. That was actually at one point law, that there had to be somebody to push the button. So of course the laws changed. And of course Ford, you know, he had to fight this, and there's a great quote from Ford. If I asked the user what he wanted, he'd want a faster horse, and not necessarily Model T. And I don't know exactly the law, but I guess for a couple of years, and I don't know if it was across the United States, but I know in San Francisco, I know in Paris, when a horseless carriage was moving down the road, in order to protect people, you had to walk in front of it with some kind of red flag indicating that a horseless carriage was coming. So there are plenty of times in our history where these kind of activities, technologies which are totally changing the way we lived and functioned, were deemed as unsafe until somebody kind of had the cojones to say, we're going to do this. So the next one, final one here. So this idea of a living laboratory, and this is what I'm really been pushing. And you know, maybe my legacy is I'm getting ready to retire already here, but this notion of we need to run robots in a realistic environment, not just in some kind of environment that is, I want to say tricked out, but an environment where it interacts with a society, whether it's people in a building, and I point out military bases, and I even call it autonomous robotics for installation and base operations, where we're doing transportation, protection, and logistics. And I mean, there's just 3 examples what I saw: robots in buildings, robots on post, doing transportation, logistics. Robots in buildings could be doing package delivery, could be doing warehousing, which they're already doing, and then actually taking robots on the road, maybe shuttle service and stuff like that. So there's a lot of, I've been pushing this, and now finally, one of the things I think is a success for me, one of the people that I look up to, Lieutenant General Vane at ARCIC, actually in a briefing recently talked about the notion of a rebo, and he thought this was a good idea, and now it looks like finally, you know, they always say if your boss says it's their idea, then you've won. And so one of the guys who I really look up to is now saying, we need a test bed, we need a living laboratory. So that's the way we're going, and the living laboratory idea is now pulling in those sectors of the community. So that means the automotive's interesting, they're coming to us now, how do we get our vehicles on there? And so we've been talking to them, we've been talking to the Google guys, who of course put robots all over the roads in Southern California. So these are real exciting things. And if the military is going to do something like that, then the commercial and consumer space needs to do something like that. And that's a nice setup for when you'll hear the panel. I think, Corey, you're going to mention something about Robot Town, which would be a commercial and consumer version of this, where, again, can we come up with this notion of robots interacting with humans in a safe way, and to really learn basically why they do certain things. I mean, let's build them, let's test them to fail, and go back and figure out, do the root cause, why it failed, and make it better and make it safer. So I went a little bit over, but that's my talk, and I don't know if I have time for questions.
How about 2?
Sure.
2 questions from the floor. Great talk.
I'm interested in attending the event tomorrow.
Just talk to me I'll be here all day. Yeah. Yes, sir.
When you said put robots in realistic situations, what is it kind of unrealistic, or you say realistic?
Well, I mean, so like for example, right now when I have to test, I mean, in fact, the one film didn't show, and we don't have any humans in there, but when I have to, and I understand. So and it's a matter of energy transport. I mean, so when a small robot is moving at 1 mile an hour, if it hits your ankle, you know, that can hurt. It's not necessarily going to kill you. I guess I can come up with some situation. But when a 6-ton Jeep, even running at 1 mile an hour, it could hurt you. So what I'm interested in doing is currently, right now, we're not supposedly allowed within 100 yards of a moving autonomous vehicle, which is unrealistic in terms of testing these vehicles. I need to have some kind of infrastructure put in place, some kind of barriers to allow me to understand what it's doing. And there's a cultural aspect to understanding and accepting robotics. So my thought was a military base is somewhat of a small little village, with the commanding general in some ways having the mayor of the town, if you want, so to speak, where he can meet with his board of directors and say, okay, we'll allow this to run. Show me how you're going to do it. Like, for example, what I'm trying to do at TARDAC is just run it 2 days a week, 2 hours a night, just to collect data. I just want to run a loop. It'll be at night, 5 to 7. Hardly anybody's on post at that point. Actually, we did at 2 o'clock, and hardly anybody's on post. I didn't say that out loud yet. I'm kidding. But we would run that just to start acquiring data, because first and foremost, we have to start gathering data in realistic environments. So I would have a driver sitting in there, much like Google did. I'd have a driver who could, if they had to, take over the car in the event that something like a person walked out in front of it. But I want to start gathering the data in a more realistic environment, not a lab setting, not a test course, but an actual, this is where people are every single day. So that's kind of one of my notions, to start the logical progression from the great work that was done at the DARPA challenges, but that was still a very specific, very focused approaches toward technology and toward pushing the envelope further. We didn't do our due diligence to keep that going. We needed to go into much more realistic. So this is my attempt at moving it beyond the DARPA challenge into more realistic environments.
Very
I guess some of the convoy technology that's already been developed, what's the graded, or what's holding that up, getting that to the warfighter?
Well, there is a safety issue. There is definitely a safety issue. We have some of the technology right now. I think the community does have very specific processes and process that they go through to accredit this kind of work. So it's one of the things, again, not only it's not necessarily even requirements, I didn't even bring them up, but it's also working with the testing community to understand exactly what the systems will do, and can be able to, if you want to call it, bound the performance of the system. So it's something we're currently working with. Right now, the military, under certain conditions, it's up to the commander who's actually getting this technology whether he wants to use it. But a lot of times this technology comes with a caveat that it's high risk. So it's up to a commander if he wants to use this for his particular platoon or squad or whatever it is. And so that's one thing that we're, again, trying to collect data to let them understand where are the notional concepts of when things will fail and when they'll be successful. And so, but with that, data collection needs to start happening, and that's what we're trying to really start pushing forward now.
Hey, any other questions? Jim's going to be around all day.
Yep.
Right? So
Yep.
please see him. Thank you.